polynomial roots. It's fun to say. Polynomial roots. Polynomial roots. That's what we're finding today. We're finding polynomial roots. So roots of an equation are the solutions of the equation. So today, lesson 76, we're going to find polynomial roots. Boom. Let's go.
Flack math! Give me some math and I'll give you some flack. Flack math!
All right. So we're just going to jump in. Let's start with example 1. 0 equals 2x times parenthesis x minus 5 times another parenthesis 2x minus 3. You know by the zero factor rule in multiplication, if you have a 0 as an answer to a multiplication problem, then one of those factors has to be a 0. Not all of them. They don't all have to be zeros, just one of them. So, since there are basically 3 factors here, we're going to set them all to 0. Okay, so if this has to be 0, 2x equals 0, then this x has to be 0. If this has to be 0, then we set that to 0, x minus 5 equals 0. Well, add 5 to both sides or just figure it out, x equals 5. This one's a little bit more complicated, but you can still do it the same way. There's a little shortcut that we talked about before. If you solve for this equation, adding 3 to both sides, and then divide by 2, x equals 3 halves. So these are our zeros. So the shortcut to finding a 0 to that is going to be this number 3, actually the opposite of that number, over 2. So this number goes there, and this number goes there. So the roots of these equations, the roots are 0, 3 halves, and 5. So usually when you write the solutions, it's nice to put them in numerical order. So 0, 3 halves, 5. Okay, let's move on to example 2. Find the zeros of this polynomial function. F of x equals 6x cubed plus 10x squared, oh my, plus 4x. All right, we could do this. So first step to solve by factoring is to find a greatest common factor of these 3 terms. Is there? Why, yes, there is. So keep in mind the numerical factor and the variable factor. So what goes into 6, 10, and 4? 2 goes in there. What goes into x cubed, x squared, and x? X. So take that out of there and you're left with 3x squared plus 5x plus 2. All right. Now we've got this trinomial. So we're going to factor this trinomial. It makes it a little bit more complicated because of this coefficient, but not too bad. So we're going to start with our parentheses, 3x and x, because 3x and x are the only 2 things that can multiply to get 3x squared. So we're going to start there. Now, luckily, there's only 2 factors of 2. So we can either say 1 and 2 or 2 and 1. So there is a shortcut to find this, but I think it's faster to just trial and error your way home. So let's FOIL this out and see if this works. Everything's positive, so everything stays positive in its factors. 3x times x is 3x squared. We already knew that. Then we get a 6x and x. So 6x and x equals 7x, not 5x. So that doesn't work. So let's try that again. Now we're going to reverse it. 2 and 1. Now when we FOIL it out, 3x squared, and then we get 3x plus 2x, which is 5x. So that works. All right, so now, since we're setting this equal to 0, because we're finding the roots, let's see what x's will make this 0. So we're just going to say that's 0, because that's the only number that you can substitute for x that will make that factor 0. 2x needs to be 0, so x equals 0. All right, now the shortcut here is we're going to take the opposite of this. Okay, so -2 over this guy. So that goes there. All right. And then this guy, x has to be -1 for that to be 0. Okay, so how do we write our solution? Let's say roots are -1, -2/3, and 0. We wrote it in numerical order. That makes me feel all warm inside and neat. So there's a B to example 2. We're not afraid of 2B. Find the real solutions of this guy. F of x equals x to the 4th. Oh my. Minus 3x cubed plus 2x squared minus 6x. Okay. All right, so set that to 0. Let's take out some factors. The only factor I see that they have in common is the x factor. So x cubed minus 3x squared plus 2x minus 6. Okay. Now we're left with an x factor and a cubic factor. So this cubic factor is a little weird, but let's graph it and see what happens. So here's our graph. Y equals x to the 3rd minus 3x squared plus 2x minus 6. Okay, so let's see what this looks like. So we can see, so remember when we're finding our factors, we're finding where y equals 0. Okay, so what x's will make y 0? Well, where y is 0 here is at 3. So now we can say that one of our factors is going to be x minus 3. So this is going to be 0 equals x times x minus 3 times something. Well, how do you figure out what this something is? Well, this times this has to equal this cubic factor. So what do? Opposite of multiplication, division. So we're going to divide this big polynomial by x minus 3. That's okay. So we can do it two ways. We can do it synthetic division or normal division. I'm going to do both because I can. So x minus 3 divided into x minus 3 divided into this big guy, x cubed minus 3x squared plus 2x minus 6. All right, remember, dirty monkeys smell bad. So D stands for divide. You're only dividing the first term by the first term. So x cubed divided by x equals x squared. Dirty monkeys. M, multiply. So when you multiply, you're multiplying this x squared times this 2-digit number, or this x squared times this binomial. So we're going to distribute. So x squared times x minus 3 equals x cubed minus 3x squared. Dirty monkey smell. So we're going to subtract this whole thing. Okay, so when you subtract, to make it easier, chicken scratch everything. Okay, these guys cancel, and you're left with nothing. So now instead of just bringing down one term, we have to bring them both down. Okay, so now we're dividing. Go back, divide again. So 2x divided by x is 2. So now multiply, distribute, 2x minus 6. So you get a 0 remainder, and this is our mysterious other factor. So now we have x squared plus 2. So now you have 3 factors. Let's see what our solutions are. So what x will make this 0? Well, 0. What x will make this 0? 3. Okay, well, what about this guy? So if I set this equal to 0, x squared plus 2 equals 0. Well, that's going to mean if I put the 2 on the other side, x squared equals -2. What happens when we try to square root a negative number? No real solution there. Okay, that's an imaginary number. So our only roots are 0 and -3. Okay, does that make sense? Okay, moving on. Example 3. Finding binomial factors to determine roots. Here we go. Find the real roots of this guy. 0 equals x plus 3 times x squared plus 4 minus x plus 3 times 4x plus 1. Okay, so now this, you kind of have to like open your mind here. So this is really two things being subtracted. And these two big chunky terms have something in common. They both have an x plus 3 in common. So we're going to take out this factor, this common factor, x plus 3. And what are we left with? We're left with x squared plus 4 minus, okay, so remember this is reverse distributive property, so we're gonna have to add another parenthesis. 4x plus 1. All right, so now let's just clean this up a little bit. So we're still left with that x plus 3 on the outside, and then on the inside, we're gonna combine these terms. So what I'm gonna do is I'm gonna chicken scratch. I'm gonna change the color here so you can see. I'm gonna chicken scratch this whole parenthesis because we're subtracting this whole parenthesis. So that's what we're adding. So we have x squared, and then we have a -4x, so minus 4x. And then we have a 4 plus -1, so that's a 3. All right, so let's keep going. This is still factorable. So we're gonna rewrite that, x plus 3. And then this is gonna factor. So remember, the magic question, after you put your parentheses, your cheeks and tats, you're gonna have -3 minus 1, because these two numbers multiply to get +3, but add to get -4. So when you have a trinomial with no coefficient, the magic question is, what two numbers multiply to get the last term, but add to get the middle term's coefficient? So it's kind of like a riddle. It's really fun. So -3 times -1 is a +3, but -3 plus -1 is -4. All right, so here's our solutions. That's pretty darn easy. So our roots are just -3, +1, and +3. So -3 would make this 0, +1 would make this 0, and +3 would make this 0. Yay. Okay, example 3, done. Oh, there's a B. So it's not done. All right, okay. So let's do B. Here we go, B. B. 0 equals let x minus 7 times 3x cubed plus 4, all added to x minus 7. There's our common factor, by the way. Spoiler alert. 5x squared minus 1. Okay, so our common factor is this x minus 7, so let's grab it out of there. And we're left with 3x cubed plus 4 plus 5x squared minus 1. Now, why didn't I put parentheses here and I put them up here? Well, when you're adding two sets of parentheses, then you don't need to be concerned about subtracting and chicken scratching and all that weird stuff. So you can basically ignore the parentheses when you're adding two sets of parentheses with terms inside of them. Okay, so let's just clean this up a little bit. Really, there's only these two terms that we can combine because they're like terms. So we're left with x minus 7 times 3x cubed plus 5x squared plus 3. Okay, so now we have one of our roots, which is 7, but we still need to figure out this cubic. Okay, so let's graph that sucker. So instead of just graphing this equation. So y equals 3x cubed plus 5x squared plus 3. I'm going to set this equal to 0. 0 equals 3x cubed plus 5x squared plus 3. So when I do that, what happens is it graphs it right there, and I can see what my root is. So this is a very long decimal there. So we're going to write that. We'll just round it to the nearest thousandth. So let's come back. So now our root is x equals negative 1.934-ish and positive 7. Okay, so that's example 3. Example 4, we'll do one more. All right, so let's write down our equation, and I'm gonna have you press pause and you can try it. So example 4, 5x to the 4th equals 5x cubed minus 8x squared minus 2x. Okay, I lied. I want to give you just a little shove in the right direction. Okay, so remember when we're solving by factoring, it's great to have everything on one side with 0 on the other side, right? So we're going to put it all on one side. Well, the side that makes sense is the left side. So put everything on the left side because the fourth term is positive on the left side. So it's always good to have your first term positive. So put everything on the left side and then then you'll have 0 on the right. Then so I've said too much. I've said too much, and I've said it awkwardly. So the book says to do it a different way, but I don't want you to do it that way. Put everything on the left side, solve by factoring. Okay, so press pause. Okay, welcome back. I hope you've enjoyed your last example for this lesson. So we're gonna put everything on this side. So 5x to the 4th stays there. When you bring everything over, all you have to do is negate them. Negate just means change the sign, oppositize them. So this is our same equation, but with everything on the left side with 0 on the right. Okay, take out your common factor, which is only x. So now you're left with 5x cubed minus 5x squared plus 8x plus 2. Okay, so we have one of our factors, that's going to be 0, but we want to know what will make this 0. So we're going to graph that again so we can get our solution. Okay, so come over to your graph calculator. 0 equals 5x to the 3rd minus 5x squared plus 8x plus 2. So let's click on that, and our solution is negative 0.21492466167776. Don't write all that out. So we're going to give our roots and our solution here. So x is approximately, because we're going to round this, negative 0.2149-ish, and also x equals 0. So those are your roots to example 4. Boom. Okay, if you want to do example 5, the real life application, whatever, you can do that. But that's it for lesson 76. Awesome, good job. So lesson 77, we're going to talk about the law of cosines. Stick with me.
Flack math! Give me some math and I'll give you some flack. Flack math!